Hi dear students, welcome back to computer science class. In our previous session we have seen what a queue is. Queue is simply a linear data structure or a sequential data structure with two ends, front end and rear end. And the insertion operation is performed through rear end and deletion is performed through front end. And insertion is called push, deletion is called pop. And the information processing order is FIFO, first in, first out, or first come, first served. Then today we have another very important topic, the implementation of queue. And we implemented queue as a list. You know the features of list. List is a dynamic data structure with have no specific size, right? Fixed size. Then list can contain heterogeneous elements. So when we implement queue as a list, we will have the properties of queue as well as list, right? The operations are performed as a list and the structure will be means operations are performed as a queue and the structure will maintain as a list, right? Yes. So these are the main operations which can be performed on a queue, right? The first, creating a queue. Just like creating a stack, we can create a queue, then inserting element into queue, then checking for empty queue. Fourth one, deleting an element from a queue, and finally traversing or displaying elements. Okay, these are the operations, and these are the operations we have discussed in the case of stack as well, right? Okay, yes. So we can look at one by one. The first, creating a queue as a list. Creating a queue as a list. You know how we have created a stack. We have created a stack using the function list or using square brackets, right? So here also we are following the same. And okay, when we create list, it creates a memory. Means it creates memory, bunch of memory in computer. Then it can store any number of heterogeneous elements. As I've told you, we implementing queue as a list. The meaning is, the logic is, the operations performed will be of a queue and the structure will be maintained as a list. Meaning, you know the structure of the features of list, right? It can contain heterogeneous elements. It can store any number of elements. That's what this point is, which can store any number of heterogeneous elements. Okay, then it contain or it creates a memory. Okay, yes. And here is the two different ways to create a queue. Queue as a list. Queue equal to list function. You know, using list function we can create a list, right? And here queue is created as a list, and the second, queue equal to square brackets, which creates, both these statements create empty queue without any elements, right? Which creates an empty queue without any elements. Then the elements or the positions will be of this kind: queue of 0, queue of 1, queue of 2, means it goes on, right? So this is how we can create a queue as a list using the function list or simply using square brackets, which creates an empty queue, right? And the indices or the elements will be at queue of 0, queue of 1, queue of 2, and so on. Okay, yes. So this is the first operation which can be performed on a queue, creating a queue. Just before performing any operation, you'll have to create a queue first, right? That is what we have done. Yes. And the second operation is inserting element into a queue, or we can say what, push. We perform push. As we know, queue has two ends, front end and rear end. And at the time of considering push operation or inserting element into queue, our main focus will be on rear end, because insertion operation is performed through rear end, right? Yes. So insertion is performed at rear end, and just after inserting one element, for the next element to be inserted, the value of rear to be incremented. Okay, we'll look at that. Then we know it's very simple. We don't have to define our own function. We don't have to define user defined function, because there is an inbuilt function append, which is a part of list, right? Which is a part of list, and using append function you can simply insert element at rear. Okay, and the value of rear will be incremented by default. Okay, by automatic. Okay, it will be automatically incremented. So it is very simple. It is very simple operation. The operation seems to be somewhat complex, but the implementation is very simple, right? Using append function. Okay, yeah. So with the help of an example, we can see the status. Okay, the status of the queue after inserting items. Okay, yeah. So first we have an empty queue. This is a queue. Okay, at present we have this is the status of the queue. We have suppose we have 5 locations. Okay, yeah. We know there is not fixed size for the practicality we are taking only 5. Okay, yeah. So initially we have an empty queue without any elements. Yeah. Then after inserting one item, after pushing one item, it will be inserted at 0, right? So initially front and rear points to 0. Initially front and rear points to 0, and after having one item to be inserted into a queue, front points to 0 and rear points to 0. Okay, meaning when we have only one person in a queue, both front and rear points to that person, right? That's the logic. Okay, then after having one more item, queue, we have implemented queue as a list, so queue can contain heterogeneous item. So the second item is inserted as an alphabet A. Okay, yeah. So at the time front points to the same 0, this 0, then rear points to A, and you can see one thing. Just before that, having one item, rear points to 0. After having one more item, rear points to 1, meaning rear is getting incremented, right? At the time of insertion, the value of rear will be incremented. Yeah. Then suppose we have 4.5 as a third element. Okay, at the time front will be 0 and rear will be 2, because 4.5 is stored here in what, 3. Okay, yeah, here in 2. Okay, these are the indices. Okay, yeah. So yeah, after inserting 4.5, which will be at 2 and rear points to 2. Okay, yeah. Then the next item, we are inserting 99 as a fourth item, which will be placed at the third index 3. Then front points to the same 0 and rear points to 3. Okay, this is what insertion operation is. This is what push operation is. Okay, it's very simple. Push means inserting element into a queue, and we have created a queue as a list, right? So it's dynamic, it's heterogeneous. Then we perform insertion operations through rear end, and we don't have to define our own function or a user defined function to perform this task. We have the function append. Okay, at the time of implementing coding, we use append function. It will insert element at the rear end. Okay, yes. So here we have a status of the stack or queue after inserting items. Okay, initially queue is empty. Then after having one item, rear points to 0, front points to 0. After having two items, front points to the same 0, rear points to 1. And after having 3, 4, okay, the value of rear will be incremented because we perform insertion through rear end. Okay, then we can look at the algorithm. Very simple. We start, okay, then element equal to input, enter the item to be inserted into the queue. Okay, so that element, the value will be like 38, A, 99, okay, whatever it is, 4.5, yeah, which will be placed, which will be stored at element. Then using the function append, q.append element, it will place the element at the proper position on the queue or in the queue. Okay, yeah. So the implementation is very simple, but the operation seems to be something somewhat complex, right? Okay, leave it. Yeah. Then finally stop. Okay, so this is all about inserting element into a queue. Okay, our next operation is checking for empty queue. When we do check for empty queue, at the time of deletion or at the time of printing the queue, right? When we perform deletion operation or pop operation, we have to check whether the queue is empty or not, whether there is element or not. If there is no element, we don't have to proceed, right? And at the time of displaying also, if we check for empty queue, if the queue is empty, we don't have to proceed further. That's a use of checking for empty queues. Okay, as we have seen in the case of stack, here also we have the same set of algorithms. Okay, we can follow only one difference. There it is stack, the operations follow stack. Here it is queue. That's the only difference. Okay, yeah. So here is the first algorithm. First we have start. Then if queue is equal to what, square brackets, it shows empty, right? Empty list. Yeah. If queue is equal to empty square brackets, it shows queue is empty. Go to step 4. Fourth step is stop, right? Fourth is stop. Otherwise, if the queue is not empty, you can pop, right? Element equal to q dot pop of 0. This pop of 0 will be discussed here in deleting element or popping element. Okay, yes. So here is the first algorithm using if q equal to empty square brackets. It shows empty list. Okay, if the queue means the queue is empty. Then or we have the second algorithm we start with second. Okay, 2. Yeah, the first is of course start. We know that. Then second, if not q, in the place of q equal to, if q equal to empty square brackets, here it is if not q. If not q in the sense the q is empty. Okay, using the not operator. If not q, meaning q is empty. Print q is empty, go to step for first step is stop. Otherwise, element equal to q dot pop of 0. Okay, the same. Or if not len of q, if not len of q in sense there also we applying not operator. Okay, it means q is empty. What print q is empty, go to step 4. First step is of course stop. Otherwise, third step is q dot pop of 0. Okay, so these are the 3 different methods, 3 different ways you can check for empty q. As we have checked in the case of stack, the same. Okay, like if what q equal to empty square brackets, or if not q, or if not len of q. Okay, or if not q, if not len of q, it means q is empty. Otherwise you can pop, or otherwise you can display whatever you want to perform. Okay, yes. So this is how we can check for empty q. Yes, mainly at the time of popping element or displaying element, traversing. Okay, yes. And we have the fourth operation, deleting element. You know, deletion operation is performed through front end of the queue, right? We have already performed the insertion operation through the rear end, but deletion is performed through front end of the queue, front end of the queue. Okay, and in the case of what insertion operation, we know we have seen the rear, the pointer or the variable rear gets incremented after each item has been inserted onto the stack or into the stack, right? But here at the time of deletion operation, the front will be decremented. In the case of insertion, rear will be incremented. In the case of deletion, front will be decremented. Okay, yeah. Hope you got the logic. Yes. So it performs the operation through front end, and the value of front will be decremented, and we know increment and decrement will be performed automatic, right? At the time of applying append function, it will be incremented by automatic or automatically, and at the time of applying pop or delete statement, pop function or delete statement, which will be decremented automatically. Okay, yeah. As we have seen in the case of push operation, we don't want to have or define user defined function. Okay, because we have append function, built-in function append. That's the simplicity of Python programming language. Everything is available, we just have to apply it. Okay, but in some other language we'll have to implement it by the user itself. Okay, means it may be getting complex, but here it is getting very simple, very simple. Yeah. So then, okay, we know the specialty of pop function, which returns the deleted element, right? Which returns the deleted element to the variable. Yeah, so you can print it out. Okay, yes. So these are the syntax: list dot pop of I or list dot pop of 0. Pop of I means it's optional, of course, you know that. Okay, because it deletes from the beginning. Okay, so you can apply delete pop of 0, delete what list dot pop of 0, or you can apply delete statement. Okay, either you can apply use pop function, or you can apply delete statement, delete list of 0. Okay, list dot pop of I or list dot pop of 0, or delete what list of 0. Okay, then we have an example. With this example we can make it somewhat very simple. Okay, yes. So we have 4 elements here in the list or in the queue. Okay, so front points to 0, rear points to 3. You know why? Front points to 0, front always points to 0, and rear points to 3, because the last item 99 is at 3, the index 3. Okay, so rear points to 3. Then which item can be deleted? The element which is at the front. Here 38 is the value at the front. That's the element at the front. Only that item can be deleted in the case of a queue. That's it. Okay, we know we are implementing queue. There is no such default concept there in any programming language. We are implementing the concept. Okay, the concept is somewhat same everywhere, but you have to implement it. You have to implement it, showing the steps. Okay, showing the operations, restricting the operations. That's the correct statement. Restricting the operations or limiting the operations. Okay, meaning limiting the operations in the sense limiting insertion only through rear end, and limiting, restricting deletion only through front end. That's it. Okay, yeah. Then we have 38. After deleting 38, applying either pop or delete, what 38 will be deleted, right? So we'll have an empty space here. What happens in the case of a real queue? Suppose the first person got deleted. Okay, what happens? The second person move to the position of the first, right? Which fills the gap. The second person fills the gap of the first person, right? That's a logic. That's a logic we are applying here in computer programming also, here in Python. Okay, especially in Python. Okay, yeah. So in some other programming language, the concept may be changing. Okay, yeah, we are not going to it. Okay, yes. So after deleting the first item 38 or item at front 38, A will be shifted. The second item will be shifted to the place of the first, to the place of the deleted. Simply we can say fills the gap. Okay, yeah. As we can see in the real queue, in the case of a real world queue. Okay, yes. So A will be shifted to this. Then rear. Okay, in the first case, rear have the value 3, has the value 3, and after deleting one item, it shifted the entire, all the elements shifted to, okay, decremented, yeah. At the time, rear points to 2, and the steps, or it follows, okay, it goes on, yeah. And finally, we got an empty stack, okay, we got an empty stack, okay. So this is how we can perform delete operation, and as I've told you, there is no need of defining a user-defined function, okay, having a user-defined function, because we have pop function and delete statement which will delete the element automatically, okay, and fills a gap, as we could see in the case of real world queue. That's it, okay. So hope you got it. Yeah, here is the algorithm. Start if q equal to empty square brackets, or you can apply what any of these, right? If not q, or if not len of q, yeah. Print q is empty, go to step 5 is stop, of course. Otherwise, element equal to q dot pop of 0. What happens? Element at zeroth index will be deleted, will be popped out, and will be stored at element. As we have already told, as I've told you, pop function returns a value, okay, of the deleted value. Yeah. So it will be stored at element, okay, meaning deleted element will be stored at, pop function returns the delete element and will be stored at element. That's it, okay, yeah. Or you can apply delete q of 0, okay, delete q of 0. So this is how we can perform deletion operation. It's very simple, okay, yes. And finally we have traversal or display operation. You know the purpose of applying traversal operation. Traversal means, actually the concept is visiting each element one after other. That's what traversal is, okay, yes. But here we perform traversal operation at the time of displaying element, or at the time of performing some other kind of operations, okay, yes. So we'll explain this traversal or display operation with the help of an example that will be discussed in the next class, okay, yes. So traversal is one of the main operations, of course, yes. We are coming to it, okay, yes. So these are the operations or the implementation of Q as a list, and we have seen set of operations. First we have created a list using the function list or simply square brackets, okay. Both create an empty stack, and memory will be allocated to that, and we can store heterogeneous elements, of course, as we have implemented through as a list, okay. And second we have the second operation is inserting element into what's Q. Inserting element means pushing element, okay. And in implementation we are using append, the function append, and you know the logic. We have 2 pointers, front and rear, 2 variables, front and rear. Initially front and rear points to 0, no elements, okay. After having inserting each element, means element one after other, the value of rear will be incremented. We know that, okay, yes. The third operation is checking for empty q. We have 3 different ways. If q equal to square brackets, empty square brackets, means it's an empty q. If not q, empty q. If not len of q, empty q, okay. You'll have to stop the operation, yeah. Then pop, deleting element from a queue, and we are performing it through function pop, or using the statement delete, okay, yes. So in the case of insertion into a queue, rear gets incremented, and at the time of deletion from a queue, front gets decremented. Have you got the logic? Yes. So with the help of this example, we could explain it, okay, yeah. Then algorithm, of course, and finally we have traversal operation or display operation. So these are the operations, or these are the different ways to implement Q as a list, okay. In the coming class we can have some examples through that examples, the concepts will be very clear to you. Okay, so this is all for the time being. Just go through all these topics, okay, seriously, and have more practice on this. Okay, so thank you for watching. Have a nice time.